So what's interesting about the first assignment you did and this assignment is they're actually very much the same. I just have the problems that we're going to use to try to find the pattern all written in this section so that we can compare answers here, and that'll be what starts the next section of notes to find the shortcut. All right, so we're still using the derivative. We're still using that limit. I hope at this point you're getting good at this idea of, figuring out what your f of x plus h is. I think I'm going to need a little more room for this one. So f of x plus h, I'm just going to replace my x's in the original function with x plus h. So I'll have 2 times x plus h squared plus 1. And then once again, I'm hoping by now that you are able to multiply that x plus h squared pretty easily. That's one that you're going to see a lot, not just here, but once you get to calculus. And then distribute the 2. So we have this expression that I can then use in my limit. So this is going to go here, and then we have this expression will go right here. So let's go ahead and write it all out. So I've got the limit as h approaches 0 of f of x plus h, so that's the green, 2x squared plus 4xh plus 2h squared plus 1. And then minus f of x, which we know is in the white there. That's the original part of the problem. And there you have your expression. Now it's just a matter of kind of simplifying without rewriting that whole numerator again. Look, I know 2x squared minus 2x squared is going to be 0. I know 1, look, minus 1 is also going to be 0. So I don't need to go ahead and rewrite it every time. Once you've done this enough times, you're going to become a little bit quicker at recognizing what's going to become 0, and it'll get you to this point a little bit faster. And I know, again, that I'm going to be able to factor out that h, so I can create a giant 1. That's always my goal, is to try to create a giant 1 with that h. And at that point, it's when I can plug in 0 for h. Once I've eliminated the h in the denominator, now I can just go ahead and plug in 0. So I will have 4x plus 2 times 0, which is just 4x. So the original problem, f of x equals 2x squared plus 1, led us to the derivative of 4x. And I'm writing this because that's what we're going to start with in the next set of notes.